Good morning, students. So, last class we have discussed about design of gusset base plate. So, I already explained what is meant by gusset base plate. In this way, the load which acts more than, so more axial load, the load which acts more axial load on column, then gusset base plate is provided. So, yesterday we have discussed the design procedure. Now, we will take the example problem. So, here example problem is a column ISHB, so Indian Standard Heavy Beam 350 at the rate 661.2 Newton per meter carries a factor load of 1700. So carries a factor load of 1700. So here given factor load, so no need to multiply with 1.5. Okay, carries a factor load of 1700 kilonewtons. Design a suitable welded gusset plate. So suitable welded, so it means we should design welded. Okay, suitable welded gusset plate which rests on M15 grade concrete. Which rests on M15 grade concrete. Okay, so design the gusset base plate. So assume the suitable values which we needed. Okay, so here we should design the gusset base plate for ISHB 350 at the rate 661. Okay, so here first one, given section and properties from table book. From table book we have taken ISHB 350 at the rate 661. So depth, width of line, thickness of line, web, thickness of web. So we have taken the values and also given factor load So here bearing strength. So first step is bearing strength, calculation of bearing strength. Already we have discussed before for slab base plate and gusset base plate. The first step is same. So this is the bearing strength of concrete, which 0.45 into FCK. 0.45 into FCK. So here comes 0.45 into FCK. 0.45 into 15. So we will get the value 6.75 Newton per mm square. This is the bearing strength of concrete. Second step, area of base plate. We know the formula PU by 0.45 FCK. PU by 0.45 FCK. So 1700 into 10 cube by 6.75. We will get the value 251.85. Okay. So this is the area. So now we should provide the thickness. So why? Because for third step we want the formula, we want the value of TG, that is nothing but thickness of gusset plate. So here the thickness of gusset plate should not be less than thickness of column flange. So here thickness of gusset plate value should not be less than thickness of column flange. So if this value, so the gusset plate value should not be less than this value. Okay, so we should take greater than TF. So 11.6. So I have taken 16 mm. Thickness. Let us provide. We are assuming. Okay, so I write the step of let us provide. Okay, so let us provide 16 mm thickness. So we will get the value of minimum width B is equal to BF plus 2 into TG. So we know the value of BF 250 plus 2 into TG 16 mm we have provided. So 400 mm. So let us provide base of 400 mm. So here base, we get the value of base value, we get the 430 mm. So we want to get the length value. So how we know that? Let us provide. So length. So area is equal to length into width. So we know the value of width. So L is equal to area by width. So area 251.85 to 10 cube by width 400. We get the value of 629.6 mm. So we have taken 630. This is the length value. So providing base plate of 630 mm by 400 mm, which is base plate, which is in size. So this is the inner heavy section, ISHB section. So this is the width of flange 250, depth 350, and the thickness of flange is 11.6, and the thickness of web, this is 8 point. So here becomes the third step, minimum width. So first step bearing strength, second step area, and again thickness we have to assume, which is not less than TF. Third step, a minimum width, fourth minimum width, and provided the base plate of size 630 by 400 mm in size. Okay. Next step, check for buckling. So already told what is by buckling. So where the column tends to bend, is called buckling. So here first step, D less than or equal to 29.3 epsilon Tg and S0 less than or equal to 13.6 epsilon Tg. So here we know the values of epsilon is root of 250 by Fi. This is 1 and the Tg, thickness of gusset plate, as 16 mm. So substituting the values, D of flange, depth of flange 350 less than or equal to 29.3 into 1 into 16. We got the value of 468.8, hence safe. Next, here comes, this is the main important one. So when S0 is nothing but outstand flange width. So this is the outstand flange width. So here we know the base plate 630 and here I section 350. So in 630 minus 350 we will get 280 value. 630 minus 250 350 we get 280. So by 2 we will get the 140 and 140 distance here. So again here we are assuming the height of slab is 100 mm. Height assuming. So here 100 is we are assuming the value, and from here to here double the value. So 100 means 200, 200 means 400, 400 means 800. So here double the value, here double, okay, double the value, and we will take the triangular section of this one, okay, here triangular section. So this is 140, this is 100. Why? Because here to here 100 and S0. So here S0 L minus D or 140. This is a one method. L minus D by 2. We can take value, or by like this we have taken Pythagoras theorem. Hypotenuse square is equal to side square plus side square, like this. Hypotenuse square root of 100 square plus 140 square, we will get the value of 172.04. 172.04. Here again I am saying this is 630 base width. Here 350, we know I section depth. So 630 minus 350 we will get value 280. 280 by 2, 140, 140. And here 100 is the assumed height value. From here to here 100, from here to here double the value of this height. So we will get the S0 value by taking the triangular method of Pythagoras theorem. So substituting the value of S0 here, 172.04 less than 13.6 epsilon 1 and Tg, we will get the value of 217, which is safe. Here this one is safe. In case if it fails, this check fails, increase the thickness of gusset plate. Okay. So here. So next step, we know the value intensity pressure as same as base plate. P by A1 as required provided area. We get value, hence safe. So it should be less than bearing pressure. First step, it should be less than bearing pressure. Okay, here critical section XX for cantilever moment, we get the value of C1. So how we will get the value of C1 means? So this is the C1, as is shown in the figure. This is the C1. So 400 minus 250. 400 minus 250 by 2. So here and here, you know the value of here C1 and here C1. So 400 minus 250 by 2, we have done 75. So this is 75 plus 250. So we will get the value of 400. So here we get the 75. So M is equal to WC1 square by 2. So 6.75 into 75 square by 2, we get the value of 18.95. Next, design bending strength. MD is equal to 1.2 Fi gamma m naught ZD. So here we will get the substituting T square by 6. So by equilibrium condition, M is equal to MD, we will get the value of T as 22 mm, which is greater than 20F. So providing, hence safe, providing 630 by 400, providing 630 by 400 by 22 mm gusset base plate. Okay, so here we are providing 630 by 400 by 22 mm gusset base plate. Okay, in case here check fails, we should increase the thickness of gusset plate. In case If here it should become greater than thickness of flange, the value must become P is equal to direct step. So if you have problem without remembering this, I said in design procedure directly T is equal to 2.75 root omega. So some formula. Okay, T is equal to, so T is equal to C1 root 2.75 by F5. So directly by solving this value also we will get this value 22. How? Because here root of 2.75 into omega 6.74 by F5 250 into C1 75. So 75 into root of, we will get the value some 20.4 nearly. So by remembering this formula or by solving this method, we can calculate the value of T, and we know the providing of 630 by 400 by 22 mm gusset base plate. Here up to 14 marks. If it is given for 14 marks, you can have this much only. You can do up to this method. So next class we will continue the remaining steps of connecting of gusset base plate with column flanges and column flange with beam and providing of bolts. Okay, this is the required problem for gusset base plate. For next class I will continue the problem. So please listen the video and note down the problem carefully. Okay, thank you.